Hey, this is Eric Strassheim from NextGen CAM. I'm located in Indianapolis, Indiana, and we've got three people on here. We're all virtual and coming together for this presentation. So starting off, we've got Corey Medina, who has a wealth of experience in this space. He's got 20 years as a certified journeyman in the CNC space and has done a lot with Netfab and a lot with 3D printing. He's fantastic to work with, loves to solve difficult problems, and Corey's going to be an integral part of this presentation. Myself is Eric Strassheim. I'm one of the co-founders of NextGen CAM, and I just love working with customers with the end goal of having a long-lasting impact on your business, and that's what we're trying to show with this solution today. Last but not least is Jeff Robinson, who is the founder and owner of Hybrid Machining. He's out in Holland, Michigan, and he's got some fantastic experience. He does a lot with the community out there. Jeff, maybe you could tell us a little bit about some of the things you've got going on. It was more than I could get my own arms around earlier.
Hi, this is Jeff Robinson, like he said, from Hybrid Machining. We're located here in beautiful Holland, Michigan. I just recently sold my previous business of 18 years where I did traditional CNC machining. And now I've started a new company where we're focusing on both additive and subtractive and how they work together. During this process, we're working closely with our local schools, community colleges, and tech centers to figure out how we can get our youth involved in our industry and get them intrigued to move forward with us in the future.
Thanks, Jeff. We're really looking forward to you joining us in this presentation. Hey, I got a message while Jeff was talking there from headquarters, and I guess this is a little embarrassing, but anyway, they mentioned we're going to have to wear masks. So I've got one on now, and Corey, they thought that you should have a mask. So anyway, now that we're safe and ready to move on, let's get into the presentation. When you look at the 3D printing market, there are a lot of different solutions. There's a lot of different companies and options that you have to look at. And this chart is a little bit of an eye chart. There's just a lot here for you to look at. And we're not going to go through all of these in detail. But one of the things we know and we see as we work with customers is that most of you aren't going to just settle in on one 3D printing machine. Over time, you're going to start adding different machines. There's a lot to choose from. And when you go out 3, 5, 10 years into a business, you're going to end up with a collection of different machines for different purposes, different capabilities. And this is one of the challenges. When you think about learning, let's say you have 5 or 6 different machines in 5 years, do you want to learn 5 or 6 different softwares and different platforms and the way that all of these different machines work? That's one of the challenges we see out in the market. Another challenge that we're seeing is failure. It's interesting the way that the 3D printing market started is kind of entrepreneurial and everybody's doing it. It's so exciting to be able to print something instead of making something in the traditional way. And we've all kind of settled in and people are comfortable with the current state of the industry where, you might print 3 or 4 bad prints before you get the one that you like. Here's some examples of common failure points that we're seeing at the higher end of things that are very costly. So you look at this recoder blade hit here. That's not a mistake that you want to make often. If you look in the upper right-hand corner, the geometry deformation here. So we were looking at this, and our estimate is that an average build would be between $5,000 to $10,000. And this is probably about a $6,000 mistake. And it could have been solved potentially by just doing a 15-minute simulation or some work in advance to look at it. There's also support structure failures are common. This lack of fusion with a hotspot down here, this is another common error. And we could go on and on with these challenges in the industry. Some additional common issues that people have is, packing parts and build plates and tracking all of this and making it an efficient, fluid process for folks. Also is just the post-processing. A lot of times it's left out of the discussion until later, and then it becomes a problem. But trying to plan for that in your process is a common issue for people in this industry. If we look overall at the challenges in part design with printing, one of the greatest challenges is that complexity is free, and you actually have more fidelity, more ability to produce complex parts with this as a manufacturing process. but oftentimes your design process or your upstream thought process isn't as complex. And so bringing this in and adding in complexity is almost counterintuitive to a lot of us. And it's something we have to change and think about differently in the way that we do things. Lightweighting is also obviously a big goal. You want to reduce your material costs, increase your performance. We start thinking about structures and scaffolding and the things that go around a part. There are really intricate and good ways to solve these problems, but it takes a little bit of trial and error. And so you want to be simulating, you want to be finding efficient ways to deal with that. Also in the 3D printing, there's a lot of expectations. Everyone kind of is excited, like we've got a 3D printer, we can start getting results faster. We can iterate our solutions more quickly. We can do a heck of a lot more things. And so with all that anticipation in the business, you've got a lot of stakeholders. And so often though, they're considering and thinking the cycle time is going to be quick. And if you just go about 3D printing without having a good process in place, you can be a little underwhelmed with that. Also, just limited material candidates. So you may or may not have an idea of all your different material options and how it is that you can go about solving something. When you're taking a traditional process where you knew material selection in the past and you have more options here. The other thing that happens a lot is you're going to find defects and problems in the manufacturing process, especially with bad surfaces or models that aren't exact, is one that comes to mind quickly. But how do we resolve those? And these are some of the challenges that we see in the industry. This is probably one of the biggest here. I was just talking yesterday, just by chance, to a guy that worked with Greg Morris, who was one of the pioneers in the 3D printing industry. He worked with him for 20 years, and we were just talking about the real challenge. And the biggest challenge is really an opportunity. We need to rethink how we build parts. Often what's happening is we're getting into 3D printing late in the process, when really what we should be doing is completely innovating, revolutionizing the parts and the pieces that we make at the front end and thinking with a new lens and a new thought on it. Here we have an example of a generative design with Autodesk where they're taking a seat bracket here and taking it from 8 components down to 1 part. With some advantages in strength and lightness there. And they're doing that by letting the computer come up with different iterative options that is looking for the best solution and not necessarily the solution that we've always used in the past. Down below, this is a heat exchanger. And Jeff, I really liked what you had to say at the beginning here. You were talking about education and getting young people involved. You may know more about how to tackle this problem in the real world than I do.
The part of the reason why I'm pushing so hard to get this generative design, in particular in the hands of the students and the youth, is because that they don't have a design constraint already in their head. They don't know every manufacturing process that's already out there. This way, they can think outside the box, even better than some of us that have been in the industry for 20 years. We can look at a part and we just automatically assume that it's a subtractive, and I'm thinking about how I'm going to hold the part. You can take a student who doesn't know anything about it, and they might be able to come up with a better solution than we can because they don't have these preconceived notions of how it has to be done.
Yeah, it's really fascinating to me is we have to revolutionize. We have to change the way we think. And when we take these old limitations on the process away, it's amazing to think about what the kids today are going to be doing. The things they're going to be designing with this technology as it continues to progress. Here's some of the applications, and this is just to kind of get our juices flowing and just to kind of think outside the box a little bit, in particular with prototyping. The ability to prototype something quicker can be groundbreaking on the results that you're going to get. Lightweighting and analyzing parts. A lot of this isn't even being done, and now if you can add it into your process, you can really move ahead. We look at the image in the upper right, which I think is an Under Armour shoe, but they wanted to produce something that was functionally enhanced, something that was better than what was previously available. And so here they're using it in that instance. Something that we all care a lot about is our own bodies. And, you look at how materials in the body are coming together to have better medical results. There's just a lot of opportunity there. We think of all the time spent on fixtures and jigs and supporting structures. This is kind of changing the whole game with how it is that you can come up with these. And then even moving into metal castings and patterns. There's a lot of options and things that are out there. So let's get into Netfab. This is an Autodesk solution. And when you think about it, what it's really doing is it's a bridge between the digital and the physical. It is going to help you quickly take something that's in digital CAD, which is a very accurate record that you have, and bring that into being a physical part. And you think of all the challenges we talked about with warping, and when you print, there's just a lot more challenges that we don't normally see on the subtractive side that we know really well. So some of the things that Netfab is doing in here is working on this conversion of the file and bringing it in, healing it, so to speak, supporting and scaffolding, packing, mesh manipulation, slicing the layers in there, and doing even just basic simulations so that you can get a good analysis and come out the other side with a printed and machined part quickly. This is what Netfab is doing, and it's doing it really, really well. Let's look at the workflow at just a high level. The first step is obviously we want to get that native CAD and import it in. So you're going to be able to do that really well with this solution. The next thing that you're looking at is, how do I design for additive? I want to change things. I want to have latticing. I may want to generate a completely new design that hasn't been done before, while still holding the goals and the needs of the part in mind. I may want to make a plan for the manufacturing process and make sure that it's not just the part itself, but the whole DFM, design for manufacturing, is planned and thought out. I also want to think about the print preparation. Am I making something in a way that's logical, and how is the best way to support this in the build process? And a step that often gets skipped for most folks is just simulating this. Let's go through and make sure we're going to get the part we're expecting. It's going to have a big impact on your cycle times. And then the actual printing of the part, you'll see there's an integration with Netfab into a lot of the solutions out in the market. And then obviously planning for the post-processing of the part. So what we want to do next is just take kind of a real world example. This is just kind of for fun. Corey, as he's known to do, out boating around on the lake, one day was just kind of realizing his boat wasn't as fast as everyone else. And he started thinking about propulsion and, hey, how do I get my boat just a little bit faster? And traditionally in the past, you just throw that thought away. You just say, you know what? I don't have the time and energy to get involved in something. But you throw in this Loctite printer that Jeff had at Hybrid, and pretty soon we're thinking like, hey, we can do this project. And what we want to do is kind of take you through this project and show you how we're going to go about building up this part for the first time and moving to full-scale production as the business grows over time. So first of all, we went to Jeff, and he was able to help us print the first and the second different iterations of this. I just wanted to go to Jeff next and talk about his experiences overall. And I thought it was really interesting, Jeff, when you were describing your company at the beginning, when you think about, building a brand new company from scratch, which is kind of what you've done the last year. A lot of people ask that question, if I could start all over again, what would I do? And you kind of have had that chance, and here you are, you're focused on Industry 4.0, and you've got additive and subtractive working together, and you've got 7 machines in here already. And it'd be great if you could just share some of your actual experiences using this. Would be great.
Yeah, absolutely. I purchased Netfab almost right away. Before I had equipment, I got Netfab and Fusion to start doing some of my design work. What I found right away with Netfab is that if I was going to leverage 3D printing to show off the coolest capabilities, in my opinion, are some of the latticing and so forth, is that I needed the software to generate it. You could be good at CAD, but to draw this lattice would be extremely difficult and time consuming. If I was going to do it, I needed to do it efficiently. So that's why I ended up with Netfab right away. I use it a lot for file conversions and cleaning up of STL files, even if it's for a part that I can't use directly with Netfab. I use it as a cleanup tool, bring a file in. Sometimes I actually remesh it, because if the mesh is all skewed and all the faces are not equal. And I can simply remesh it, create a better STL file, get rid of all the facets, and produce a better STL for even other technologies. So that's one of my main purposes with it. The other idea is just to use the latticing to lightweight parts. We're in West Michigan where we have a lot of automation. So people are constantly trying to lightweight components so that the robots are not having to work so hard with end of arm tooling, and other jigs and fixtures. And then kind of lastly, one of the best things I like about Autodesk in general and Netfab is that you can take the product from one and push it to another. In this case, we can use the Netfab simulation and other Autodesk tools to take the final product that we designed and then push it over to other softwares where we can optimize the lattice, make sure that it is working properly according to FEA analysis and so on. Autodesk just has the right products that allows us to completely evaluate this part and allows me to show my customer that we are making a part that is going to be legit and it doesn't just look cool, but it actually functions.
Yeah, it's fantastic. And I'm just really excited to see where you guys are going to be going with your growth. And it sounds like you've been very busy already in just the first year and a lot of stuff going on there. I think this last bullet point is really important too, is the ability to do the iterative simulation with the Autodesk products. I think is one of the key kind of unmatched capabilities that we bring to the table with Netfab. The ability to simulate, to get insight on something, to predict how something's really going to look. One of the things we've noticed in industry is a lot of people may even, they're tweaking and changing their model to be something different so that they can get the end result. And so that's kind of a broken process, if you will, is to break your model in order to get the right print. And this is, I think, something that hopefully over time will become more valuable to you too in your shop as you guys keep growing. We're going to go through this propeller example, and we're going to start at the prototype stage where Jeff was able to help us to get success on our first print and get something going. Then we're going to move into the professional stage where, hey, we needed to get a higher production volume. And then we're going to move up to the metal integration stage where customer demand just pushed us to have an even better metallic part for different performance reasons. So we're going to use this example to move through this. Corey, at this point, we're going to move over to you. He's going to take the initial part and do the prototype section. He's going to work on importing, healing the part, scaling it, duplicating it, slicing it, and printing it through the whole process.
Thank you, Eric. So we're in the prototyping stage of this propeller. And so I want to be able to print this so I can hand this off to some colleagues, some friends and family, and they can give me feedback on how well this performs as well as myself on this. So I'm going to bring this part in. And I'm going to add it into Netfab. So the nice thing about Netfab is right off the bat, it tells me if this print is ready to be printed. The little warning sign at the bottom here is telling me that this particular model that was modeled up for me could have some holes in it. It could have some flipped surfaces, and it can also have some degenerate triangles. And all of those types of issues with the model actually reduce in poor print quality and also will cause the printing process to take longer as far as calculation times and actual printing. So within Netfab, I can run a repair script. And what that does is I will automatically repair my model and let me know that it is now good to print. So now that it's good to print, we can actually start to put this on our platform and make some design changes. So I have my platform loaded here, and right off the bat, the size of the model is actually a little big. I want to start at a scaled down version of this just for my prototyping process. And that's really easy to do without losing any of the part integrity, is we can scale it down in Netfab. So what I'm going to do is I'm going to scale it down by 20%. And then I'm going to move it to the left front of my platform. So now that I got it scaled down, I actually, like I said, I want to print as many of these as possible, and I want to hand them out to people to test so they can give me feedback on them. And so I need to duplicate this. And so what I'm going to do is I'm going to duplicate this model, and I want to fill my platform. I want to make as many of these as possible for this first initial print. I'm actually going to change the distance to the top of the print bed because I can only do one row of these at a time. And so now that I've filled my whole bed, now I'm ready to generate a slice file. So to generate a slice file, I just select any of the parts that I want to slice. So in that case, that's going to be all of them. And I'm going to drag them down to the slice section. And what pops up is, how are we going to slice this? What's the layer size going to be? Where do you want to start and where do you want to end? So I'm going to start from here. And then in our slicing generation, we can actually play through and we can see how these parts are going to be printed on my platform. So right now, you can see that this is actually how they're going to be sliced. And right off the bat, I noticed that I actually want to generate a filling in these slices to fill in all these gaps. So that's real easy to do in Netfab and automated. Just select the parts that you want to add filling to and do a generate filling. So I'm going to do just a quad islands filling. And then once again, depending on your preferences for how you want the filling to be made up, you have a lot of these options: hatch distance, the width, the height, and so on. So I click OK, and you can see now I have a filling. I can animate this. I can actually reset it down, and I can play it. And so now this is how the slice file is going to be sent to the printer. Once I like what I see, I want to send this to the printer, I can go to export, and then I could export it as a universal slice file, or if you have a different format, maybe you need a slice layer interfab. We have a lot of different formats that you can send this slice out. You can also send out a CSV file as well, okay? The other cool thing about Netfab, so this is ready to go to my printer, but another thing that I wanted to do is I have a friend that has a carbon printer as well. And so he said he would print this propeller for me in a different type of material. So what I'm going to do is I'm just going to load up his printer. And I'm going to drag one of these files into his printer, and then I'm going to scale it, or actually I'm going to place it. So place it at the center of the platform. And then from here, I could actually use Netfab to send this out. So you can see we have an integration with Carbon. So you add parts, auto placement. Once this is all ready, once my supports are done, I can export the file. If I had multiple files on here, I could just export each individual part. Or if I wanted to do everything that's on the platform, I could export the job. So I could actually arrange all this for him to the way I want to have it done, and then just send him the file of the job, and he can print it for me. And so now that we're done with the prototyping stage, we're ready to see what the results are from all of our beta testers.
Fantastic, Corey. It's great to see that you've completed the prototype. And so we've kind of finished this first plank that we had in here that we wanted to go over. He's got a successful first print very quickly. And now we're going to move in to the professional stage. He's had a little bit of success in the market. The requests are starting to roll in for more business, which is what any business owner would love to hear. And Corey, we're going to move back over to you, and you're going to go and talk about your requirements for buying a new machine, adding latticing, and producing at a higher volume.
So I've gotten feedback on my part, and the reviews are great. Everyone loves them. They've actually told their friends and family, and a lot of other people have heard about them. So the demand for this part is starting to get to a point where I need to move up to a professional printer. But I also want to do a design change as well. I want to throw some latticing into this part. So to make it a little bit lighter, So I'm going to bring the part in. And once again, you can see the part's in. I don't have an error code at the beginning because with the import wizard, you can actually set it to automatically repair the part as you bring it in. So like I mentioned before, I want to make a design change. So what I want to do is I want to take this hub and I want to hollow it out and add a lattice to it. That's really easy to do in Netfab. We would just drag this into our lattice commander. And what the lattice commander will do is this will help us hollow out this part and apply a lattice structure to the inside of the part. So the first thing I want to do is I want to hollow out the part. So I click on hollow, and then what it's going to do is it's going to generate a skin. And then you just tell Netfab the thickness of the skin. So I'm going to go 200 thousandths on the thickness of my skin and hit generate. So now that I have a skin generated, if you want to see, you know, kind of a cross section of what that looks like, we can do that quick and easily in Netfab. So that's kind of what the skin looks like. And then we can drag this up to see what the skin looks like as it transitions to different levels in height. So now that I have my skin generated, what I need to do is I need to generate a volume lattice. So I'm going to click on the volume lattice, and then from here, we have a lot of different options. We can choose a topology, which is basically the cell structure of the lattice. So a lot of options are currently available in Netfab. We have grid, X, star, you know, all the way down to like a tetra. So just depending on your preferences, that's where the topology that you would pick. I'm going to stick with the grid. And then I'm also going to change the size of my lattice. So I'm going to change it to 1 inch by 1 inch by 1 inch. And so what I'm doing here is each one of my grid sections is going to be 1 inch by 1 inch by 1 inch. You can also do some things like offsetting the lattice. So if the lattice wasn't quite following, you know, maybe it was sitting right at the top and you want to shift it down a little bit, that's where you would, you know, do your offsets. You can also change the thickness. So I'm going to change my thickness to 175 thousandths. And what this is this is the thickness of the beams of the cells. So each cell would be comprised of a series of beams. And so this is what controls the size of the beams. So I'm going to click on generate. And so now I have a lattice and I have a skin. Another thing that I want to do is I actually want to edit the body a little bit. I want to remove this top and bottom surface so people can see that it's latticed. So I just go back up to the skin and I'm going to do an edit body. And so I'm going to remove the top and bottom. So I'm going to change my selection threshold to 5 degrees and I'm going to select the top. And then I'm just going to remove it. So now that this is removed, we can see the lattice inside of the part. I also want to do that with the bottom. So you can see the lattice going through the part. The last thing I want to do is I do want to thicken up this hub right in here. So I'm going to change my selection to 20 degrees. And then I'm going to select this middle hub. And I'm going to change my thickness. So if you remember earlier, I hollowed this part out and all of the walls are 200 thousandths thick. I actually want to change this to be a little bit thicker. So I'm going to change it to 300 thousandths just to thicken it up a little bit. Once we're done with making the modifications to this, we need to go back to the main page of our lattice commander and we need to generate a component. So what this is going to do is this is going to generate a lattice for us and a skin, and then it's going to trim the lattice and the skin to the actual size of the part. So I'm going to do a generate component. And so now what it's doing is it's doing the generation, trimming any intersecting surfaces and removing any open beams that aren't connected to other beams. And so we just give this a minute to generate our component. Once we have our component generated, then we'll be able to load in our new printer and fill up the platform and do a print. So now I have my old part and my new part. So this is the original part, so I can just hide this, turn the light bulb off, and then go back to my new part. And then if we want to see what it looks like, if we want to make sure that, the lattice looks good, it does. I can even do the cross section once again. So I could do a cross section of the part, just to view what the inside looks like. So the nice thing about the removing these faces is it's also a way for for me to get the excess material, excess powder out of this part when I print it. So I can see the lattice looks good, the fins look good. So now I'm actually ready to print this part. And so like I mentioned before, I'm going to use an HP Jet Fusion printer. So I'm going to load this printer into Netfab, and then I'm going to drag my newly designed part into the printer space. I'm going to scale it back down to the size of 20%. And then I'm going to move it once again to the left front platform. And then I want to do the same thing I did earlier. I want to print as many of these as possible so that this thing can run overnight. So I'm going to do a duplicate once again. The nice thing about this machine is I am able to print parts on top of parts. So I'm actually going to change my distance to ceiling to 1 inch. And then I'm going to duplicate it. So now that this platform is filled with as many parts as possible that I could print, I can actually go to the interface, and if I were connected to an HP machine, I would have the option to view the job list, edit the job settings, and export the job. I also have the ability to directly connect to HP SmartStream Build Manager within Netfab. And then also we have the ability to send the job to the machine directly from Netfab. So now that my production stage is done, this print is running, I'm able to send these out to more people that are requesting them, and ready to hear their feedback.
Wow, Corey, you're really just motoring along and moving along. Congratulations on your success and getting more of these out there. It's really fun to just watch how this can quickly build on itself and continue to expand. So as we head into the next phase here, there's some additional capabilities. We may or may not cover all of these, and I just want to make sure everyone that's out there listening has an idea of the full capacity and capability of Netfab. So if you think about, at some point you may have multiple machines. Let's say you have all 3 of these machines in your shop. You could be running all of them through one interface, through one solution with Netfab. And that's kind of what Corey's showing as he progresses. And as he moves into the metal integration, he's going to need another printer, and so he's going to go over that. There's also, I want to highlight, there's online, you can go out and you can see a full list of everything that's available, all the machines that are hooked up and connected to it. Very easy to pull this up online. You can see it at the bottom of my screen here, but it's much too long to show and go through at this point. The next thing I wanted to go over was just part orientation. And, for like DLP, you may need to find some required supports. It's a really great environment for changing angles, moving the orientation around. I kind of like just watching it because you're moving and changing the part and it's redoing all the support structures for you. You can set and use anchor points in here. You can see the load inside the part. You can adjust the transparency to see inside of the support entities as well. Just a lot of flexibility here for you as you're getting ready to print this. The next thing is the orientation recommender. And this is really good because you can set all your custom weightings. So you can set supported area, support volume, outbox volume, center of gravity, part height, unsupported triangles, and several other things that you can set in here. It's a really great environment for you to do a lot of the different things you might want to do to get this going. Next, I'm going to move over to just the automatic support creation. And the OEMs and customers all have access to this for their advanced supporting capabilities. So if they need to do more with this, there's just a lot of capability. We're showing some of them here. There's also polyline and volume are available for metal and in the middle that we're showing there. So just a lot of support. We won't have time to go over all this, unfortunately, with Corey's presentation. And then we get into editing the support. So you can see here on this screen, we're just showing kind of a light blue there. We're editing and moving that one around. And so you can get down into the detail level and work with just one of these at a time. So at this point, I'm going to hand it back over to Corey. We continue this journey into metal integration. He's going to talk about getting another new machine and orienting and supporting the parts and running through simulation.
All right, so once again, I've had great reviews on the parts, and I'm actually getting requests to print this out of metal as opposed to plastic. And it gets to a point where I get enough people requesting this from metal that it makes sense for me to buy a metal printer and prepare to print this out of metal. I definitely need Netfab's help to do that because I don't know much about support structures, and the automated support structures and orientations will help me have a successful print the first time without having to waste any type of material and time. So I have my original part here, and so the first thing I need to do is I need to bring in my printer. So I'm going to use this SLM 125. Once again, I'm going to drag the part into the build space. I'm going to scale it down to size. And I'm going to move it to the platform center. And then I'm going to use, the nice thing about Netfab is it has an interface. It's kind of like a workflow that's going to guide me into printing this part. And so the first thing I need to do is, you can see that we have a configuration file. So we're going to use this type of material. And then we can set some preferences based on what the machine manufacturer recommends. So a distance to part and platform. We can tell it what the build plate thickness is and so on. So we're going to orient the part. So what this is going to do is this is going to search through a series of orientations, and it's going to show me a lot of different options I can choose from based on what my preferences are for this particular print. So what it's going to use is it's going to use a 45-degree critical angle to calculate where the supports need to be and allow me to change to the different types of orientations based on that critical angle. So basically what we're saying is anything less than 45 degrees needs to be supported, and then anything above that, based on what the machine manufacturer has told us, does not require supports. And so what this is doing is this is actually going through all of the surfaces of the part, finding all of the angles, and then it's going to give us a series of orientations that we can choose from. And then from these orientations, we might choose one orientation at first because this is our first print. You know, maybe we want to make sure that it's fully supported. And then as we proceed in getting better with this print and getting more familiar with how this part gets printed on our machine, we might be able to change to a different type of orientation. So this is how the orientations work. So the first column is a ranking system, and so this is kind of like an average of all of these. So this is a base, I would say a best case scenario, depending on, you know, if you want the best of all of these categories. So that's what this first ranking system is. The next one is supported area. So this one is, maybe I want to support the least amount of area on this part as possible because I don't want to clean up very much of it. And so I can click supported area, and then I can click on the top ranking for supported area. So this is the least amount, and then this would be the most, okay? Support volume. Maybe I'm considered, you know, because this is something new to me and I don't have, you know, maybe I'm worried about spending a lot of money on materials. So maybe I want to orient this part to use the least amount of support volume as possible. And then we also have an outbox volume. So that's going to be the smallest outbox. Basically, it's going to create an invisible box around the part from top to bottom, okay? Or maybe we're concerned with height. we want to keep this as close to the platform as possible. So we could change this orientation to height. And then we also have a center of gravity as well, if you're concerned with this. So what I'm going to do is I'm actually going to do the outbox volume orientation. So as soon as I click OK on this, the nice thing is Netfab automatically orients my part, and so I can move on to the next step. So if we had supports created already, we can import those supports. If we don't have import supports, we can move on to the next step where we create supports. And so then this opens up our support creation module. And what we can do is we can actually just run one of the support scripts that comes with Netfab, which is good news to me, because if I was to support this on my own, I really wouldn't know where to start. And we have a lot of different options to choose from. If we were going to do this from a DLP machine, we could do DLP. Obviously, we're going to do the stainless option. But there are other options as well. There's powder-based fusion, a light style, powder-based fusion massive, and powder-based fusion strong. We also have a new DLP strategy as a tree root with anchors, so it creates a bouquet of supports where it's connected to the part, but then it has to the platform, it's just one big trunk. And then there's also this new scaffolding type of support, and what this does is this actually builds supports around the part with minimal contact with the part, and so this one's kind of nice. So like I mentioned before, we're going to do this SLM support script, and so what it's doing right now is it's using these values that have been created, and it's going to calculate where supports need to be on the part. And so right now it's using the angles, the critical angles, and it's also using the settings that we've made to create supports on this part. So now we can see this is what Netfab has done for us. And it looks pretty good, but since this is my first print, say like we want to add, maybe we want to add some extra supports, or maybe we've printed this before and we know that this part needed a little bit of extra, that we can make modifications to support. So I could select this whole cluster and I could add a little bit extra support. So I want to add like some polyline support here, just to give it a little bit more structure, help the build out. And so we'll do that there. And then we can select this cluster as well, and we can create a polyline support on that as well. And so you can see it, even though it has supports on there, we can add additional supports, to those structures. And then we'll do this one as well. And like I said, I'm just doing this because this is my first print and I want to make sure the part is fully supported. And so now that I have those on there, another nice thing that I can do is I could click on this individual support and I could edit it. So I can right click on this and I can edit it. And then these are all of the values that go with the support. So it's a polyline type, distance to part, smoothing distance. There's so many different options in here that you can change and make work, work for you. Structure properties as well. So you can set the border width, the connection. So for instance, we know that this is just kind of extra support, and so we don't need these triangles on the platform. So we can actually say no to the triangles on the platform, and it automatically removes them. So you do have a lot of flexibility when you are running supports. So when you're happy with the supports that have been ran, we can click apply support. And so what that's going to do is that's going to automatically apply the supports to our propeller. If we didn't like what we see, we could click on this next button, which is a remove support. So we could remove the supports and start all over. From there, because this is metal, we would want to start a build simulation. Once you do run a simulation, you can actually load your simulation results, and we can show this to the customer, or we can show this, to anyone that wants to see it. Maybe we need some guidance on where these hot spots are, so we can show them the the mechanical side, we can show them the displacement magnitude, and we can actually see that we have a little bit of displacement here at the bottom at the support side, but as we progress through the part, it starts to get a little bit better. And then once we run this fully through, we can see that we have a finished part here. And we can also see the displacement in X as well, and the von Mises stress. And then we can also check to see if there was a recoder blade interference. And on this simulation, it's telling us that there's no recoder blade interference. And we can close our results and we can go back to our print. So we've done a simulation, we've loaded our results. We can also do a toolpath visualization. And so what this does is this will provide an interactive playback of the generated toolpath. So once it's generated, the toolpath and its visualization will become available for examination. Basically what this is going to do is this is going to show us how this will be printed as it's being printed on our machine. So if I hit the play button, what it's doing is it's running through all these different layers, and I can pause this so I can speed it up a little bit, but each layer, it's showing us how it's going to be done with our printer. So we can scan through this, and then we have different options in here as well. We can go to change, and then these are the different settings we can choose. We can do a fully colored model. Right now, this is the one we have set is a gray model with a colored layer, so our layer is green. You can also do cut at current layer, and what that's going to do is that's going to actually show the model being built from the bottom up. So once you've looked at this toolpath and you're happy with it, you can export that build data, or we can go back. So now we've basically come to the end of the line. We've oriented our part, we've put supports on it, we've done a simulation, we've looked at our toolpath, and now we can export our build data. So like I said, because it integrates with Netfab, the last button we would need to click is this export build data, and then we would be able to send that to the print in an SLM file.
So let's get into some of the examples that we have in here. As if we were to run past even what we showed today, there's still a lot more capability than we can go through in just 45 minutes. You know, really what Autodesk is trying to do with Netfab is they're trying to bring the efficiency that we've had in the subtractive side of the market really into the additive side and simulate parts, plan ahead for parts, go through the stress and failure points that we might have, and produce good parts in the first time around that are functional, that can help the whole team make better decisions and improve cycle times. That's really what Netfab is all about. In addition, you know, we've gone over Netfab and looking at this, and one of the problems we highlighted at the beginning was that we need to look at this from a completely different perspective. And Autodesk is great because it has a comprehensive solution here. It's not just Netfab that's one piece of it. But when you look at generative design and completely rethinking and revolutionizing the way that parts and solutions are made to solve problems, Autodesk can start at the front end with the CAD solutions, with Inventor and Fusion 360, and running generative design inside of Fusion 360. Then we can come back in and do the FEA and the design visualization, which would be done in multiple different FEA solutions that Autodesk has. Then you get into your 3D build preparation and your print simulation. And then finally, if you need to add in subtractive and additive together, you've got the Power Mill and Power Inspect solutions, which have been covered quite a bit, I think, in this whole online conference as well. So if you just look at this, the Autodesk Generative Design, and there's another whole hour session, so you should look at the schedule. If you're excited about generative design, go and find the other session that goes for a full hour into this. But this is really exciting that you can do design exploration, bring in kind of the constraints, generate something, and then explore different options. And it's pretty interesting to me too to see that it ends up looking to me a lot of times like a bone structure, or, you know, the bones that are in the human body that are almost, it's like a designer or a design has been made, and that we're very efficient as humans. And just looking at this and just seeing the parts and the things that come out of it is really exciting. And it's exciting to see some of these examples. Autodesk has an example of redoing, for example, the walls on airplanes. So there's walls like to put up a lavatory, and they worked with Airbus and redid all of those walls with a thinking like this, with a lower weight and lower cost wall. It's really exciting. We'll just briefly jump over this, but Netfab automation, it has its Lewis scripting, so there's a lot of room for you to get into the further automation. There's also an advanced toolpath utility that's provided that you could take this to another level of just looking at and creating things to an even further level of complexity. And so in conclusion, we've kind of taken you through this somewhat real world example, and we've gone from prototype up to professional and to full metal integration in these parts. It's been a lot of fun going over this with you. We would love to talk with anyone that wants to learn more about Netfab, to talk to you about your projects and your products that you're making. At the end here, we've just proven that we're just a bunch of propeller heads. It's been exciting. Thanks for joining in. And I hope that you take some of these nice takeaways here. Netfab is that bridge. It takes you from the digital to the physical. It's a connected process. It's a platform for additive that you can use when your business is small, when your business is big. It's well integrated with all the OEM softwares that are out there. You can quickly and accurately improve your entire process, get the whole team involved, and deliver best-in-class results. So thank you for joining us. We hope you enjoy the rest of the conference.